The purpose of this video is a wrap-up of the human number line activity to revisit the parts of the note sheet that had not yet been completed. During the activity, you saw my niece, Hazel, and my brother-in-law, Matt, her dad, as well as many of her stuffed animals, wearing signs that represented how many fictitious tickets they had. And we're going through exercises to say yes or no if they could attend a party based on how many tickets they had. We looked at clue words and clue phrases, things like more than, less than, blank or more, at least, no more than, things of that nature. And then based on that, the animals held up yes if they could go to the party or no if they could not. And we left them plain if it was a no, and we shaded them in if it was a yes. By this point, you've also seen the different perspectives of inequalities, the verbal, the algebra, and the graph. And we're going to make some connections and bring this all together. So first of all, when we had the scenario of people with more than 10 tickets could go to the party, that is found right here on this flap representing the greater than symbol. The greater than symbol means I'm going to be using this notation. And now we can write an inequality using algebra that in that situation, you need to have a ticket value that is greater than 10. X is representing tickets. You could also use a different variable like T for tickets. The greater than symbol is graphed with an unshaded circle at the critical number and an arrow going to the right. So if the critical number is 10, I would have an open circle at 10, which I do have because it was never colored in. Bella was holding a no. And then anything to the right would qualify. So this just goes to show that the original activity matches what you have now learned about how to graph inequalities. For the second one, people with more than 12 tickets can go to the party. More than is another way of saying greater than. So the inequality would be X is greater than 12. When I see that symbol, the graph has an open, unshaded circle at that value. Originally, I goofed and I had to white that out. And then anything to the right would qualify. And that fits with our activity. Scaly qualified, Alana's qualified, and any value beyond there qualified. People with 9 tickets or more can go to the party. That is similar phrasing to this. Must be something or greater, something or higher, something or more would also fit. So I'm going to use the greater than or equal to symbol. According to our notes, if you had that kind of symbol, your graph would have a dot that is shaded in to represent saying, yes, it can equal that value, or anything higher. So I go to the critical number of 9, and I see it is already shaded in. And anything greater than would also qualify. For the fourth one, people with less than 9 tickets can go to the party. Less than 9 would use the less than symbol. So we want X's that are less than 9. There would be an open circle at that value, which there is. And anything to the left would be less than. The people with less than 6 tickets can go to the party. The algebra for that would be x's that are less than 6, or tickets that are less than 6. It would have an open circle at 6, which it currently does. Peanut was saying, no, it can't be equal to me, just less. And the animals to the left were holding yeses. For the next one, the people with at least 4 tickets can go to the party. When I see at least, that is a phrase that is connected with this symbol, the greater than or equal to symbol. And when Hazel was explaining in the video, she said that 4 was the minimum. I also see minimum listed. And she went on to continue to explain that you could equal 4, or you could be greater than 4, and that matches with this phrasing. So all of those explanations are consistent with using the greater than or equal to sign. On a graph, I would have a closed shaded in circle at 4, which I currently have, and anything greater than could go to the party. Finally, the people with no more than 13 tickets can go to the party. When we see no more than, must be no more than, we mentioned that that's like a maximum number. That's also on there. And Hazel had explained that you could equal 13 or you could be under 13. And that matched with this phrasing right here. I would have a shaded, closed-in circle at 13. And then because it's less than, anything to the left would qualify. So now, to conclude, we're taking our initial exploratory activity. Now that you've learned some more about the different perspectives of inequalities, we're bringing that together with the activity, and everything is consistent. What we already saw happening on the human number line is matching up with our verbal descriptions, is matching up with our algebra, is keeping the pattern of the graphing that we discussed, and everything is all syncing up to show equivalent ways of representing inequalities. This would be kept in your notes section, and this would also be kept in your notes section for future reference.